Now that we have learned the basic theory on straight lines, we will see how to solve questions. And from each question that I chose for you to work on, I will solve an example. So let's start with question 5E1, 1C on page 121, where you're given a point and the slope, and you're asked for the gradient intercept form. Again, you write down the formula that we learned, and then you substitute the values for y1, m, and x1. Y minus 3, because 3 is the y coordinate, equals to negative 4, x minus 7. Then, what do? We said that you do the expansion, negative 4 times x, negative 4x, plus 28, because negative 4 times negative 7 is 28. And then you move the negative 3 on the right-hand side, so it becomes plus 3. So y equals negative 4x plus 31. And this is the answer. From here you can see that the gradient is negative 4 and that the intercept is 31. And this is exactly the gradient intercept form that we were asked for. Question 2C. The general form. Now you're asked for the general form of a line that has a slope of negative half and it goes to the point 50. Again, you write down your formula. You substitute the numbers in. You expand. Negative 1/2 times negative 5 is plus 5/2. And then if you're asked for the general form, you have to pull the y's and the x's on the left-hand side. When you're asked for the general form, you have to do one more step if the slope is given as a fraction. You have to multiply the whole equation, in this case by 2, because you don't want to have rational number in front of x. You want to have an integer. If you multiply by 2, this will become 1 times x, or just x, plus 2y equals 5. And this is your general form. Maybe we can make it with green. There you go. Okay. 3C. Now, in this case, in 3C, you're not given a point and a slope. You're given 2 different points. So, in this case, first, like the example that I gave you in the theory video, you have to find the gradient yourself. Once you find your gradient yourself, so let me just do it here. 7 minus 7, in this case it is, 7 minus 7 divided by negative 3 minus 2, which is 0, divided by negative 5, which is 0. Once you find the gradient yourself, then you use it to substitute the value of the gradient in the formula. Well, in this case, you can choose whichever point here. So let's choose the first one. Y minus 7 equals with 0 times x minus 2. So y minus 7 is 0, and therefore y is 7. That's a totally fine equation of a line. In this case, if you had to draw it, it would mean that if that's the y-axis and that's the x-axis, it would mean that, let's say that this is 7, that your line is just a horizontal line, and that's totally okay. We'll see more on drawing of lines in the next lesson. 4e, it says find the equation of the line which is perpendicular to the one with slope 3/4 and cuts the axis at 5. This means if it's perpendicular to this slope, it means that the slope of the line we're looking for is going to be the opposite sign, so negative, and then you flip around the previous number you have. And it cuts the axis at 5, which axis? The x-axis. So if you imagine it, it will cut, it says, the x-axis at 5, meaning that you will have a point where the x-coordinate is 5 and the y-coordinate is 0. So the point that you have is the 5, 0. Again, now it's easy. You write y minus y1 equals mx minus x1, and you substitute whatever you have here. -4/3 x minus 5. And when it is not asking you specifically to give it into the general form or the gradient intercept form, you can give it in whatever form you want, really. So here, just give it in the gradient intercept form because it's easier. So y minus 0 is just y, -4/3 x, -4/3 times -5 is 20/3. And that is your answer right there. Next example that I chose, 5a, you are asked to find the gradient of lines that were given to you like this. The first one, it's super easy. The gradient on the first one is just 3 because the line you're given is in the gradient intercept form of mx plus c, right? In the second case, x is 2. So if you imagine, if that's y and that's x, when x is 2, let's say, it means that you have a line that it will just go through, it will always go through 2. And therefore, whenever x equals to a constant number, and that's your line, we say that the gradient is not defined. And that's because your line is vertical. In the case where your line was horizontal, let's say that you have y equals 7, for example. It means that your slope is 0, and that would be a horizontal line that you would have. Horizontal. And here is vertical. Okay. In J, you're given the what form? We call this the general form because the x's and y's are all on the left-hand side. So in this case, you need to convert it into the gradient intercept form, the equation of the line, and then you can see the slope from that. How? In the gradient intercept form, we said that y must stand by itself on the left-hand side. So first you move that 3x on the right, so it becomes 4y equals -3x plus 7. And then you divide by 4 to isolate your y. So y equals -3/4x plus 7. And now you can see directly that the gradient, wait 2 seconds, that was not right, plus 7/4. Because we divide all of the terms by 4. So here you can see directly that your slope is -3/4. And this is, by the way, how you will go from the general form into the gradient intercept form. In exercise E2, 1c, they're asking you to find the equation of the line with gradient -3 and y-intercept -2. This is super easy. You start by saying that this is the gradient intercept form, And we said that this is the slope and this is the intercept. So now it's super easy to write negative 3x minus 2. And that is your answer. On question 2, you're asked to find equations of the illustrated lines. So let's look at B. You're given 1 point here and another point there. Even though this point over there is not clear, you can see because it lies on the y axis, the x coordinate of it is 0 and the y coordinate is negative 2. So now you have 2 points, the 0, negative 2 and the 4, 3. And we saw in the theory video how you can find gradient an equation of lines with given 2 points. And same in 3b here, you have 2 points again. One of them is over there, so it's the 3, 0. And the other one is on the y-axis, so it's the 0, negative 2. Because on the y-axis, the x's are 0, and on the x-axis, the y's are 0. And again, exercise 5E3, question number 2. You're given the general form and you need to convert it into the gradient intercept form. I just showed you above, when you have the general form, meaning that x and y's are collected on the left, and you need to convert it into the gradient intercept form, you need to isolate the y on the left. So first you move your x's on the right, and then you divide by the number that y is multiplied with. And then in this case you can simplify actually. Now this is the gradient intercept form, because you can directly see that the gradient is negative 1/2 and the intercept is negative 1/6. Lastly, it says find the equation of a line which is perpendicular to this, but you're given the general form, and passes through that point. Again, in that case, first we need to find what is the slope of the line that we're given. And that 5x plus 2y equals 10. We need to convert that into the gradient intercept form. So 2y equals negative 5x plus 10. So y equals negative 5/2x plus 10/2. Or y equals negative 5/2x plus 5. Okay. So we need to find the equation of the line that is perpendicular to that one. Meaning that the gradient of the line that we are looking for is going to have the opposite sign. That's the slope of the previous one. The opposite sign, so before it was minus, now it would be plus. And you have to flip the number. So 2/5. So we're looking for a line with gradient 2/5 and with that passes through the point 1, 1. Again, it's easy. You set up the equation and you plug in your values. And you solve. I tried to solve as much as I could from the examples. So I gave you a small example from each question that you will have to solve at home. And now, what are we going to do for the next lessons, the next 2 lessons that we have? First, we will learn how to draw a line, so on squared paper. It's super nice. We will see how to find the equation of an already drawn line. So we will be given a line drawn on a squared paper, and we will try to find out what's the equation of that line. 3, we're going to look into perpendicular bisectors. You will see what's that when the time comes. And 4, we're going to do a fun project, a fun Christmas project. For example, we are going to try and draw a Christmas tree using straight lines. That's what we will do probably next week. So yeah, you will see. We'll get to that, but I'm just telling you so it's something that you look forward to. Okay.